Welcome dear students. Today we are going to discuss about the absorption and intensity shift. But before moving to discuss about absorption and intensity shift, first of all we have to understand about the chromophore and oxochrome because without their knowledge we can't understand absorption and intensity shift. Chromophore. Chromophore is defined as an isolated, covalently bonded group that shows a characteristic absorption at UV visible region. For example, C double bond C, C double bond O, C double bond N double bond N, etc. Chromophores are generally color imparting group. There are of two types of chromophore. The first type of the chromophore in which group contain pi electron and undergo pi to pi star transition. Such chromophores are ethylene and acetylene. Second type of chromophore, it contains both n and pi electron and undergo both types of transition, n to pi star and pi to pi star transition. Such chromophores are azo compounds, nitriles, carbonyls, nitro, etc. The second is oxochrome. As chromophore are color imparting group, oxochromes are color enhancing group. It can be defined as any group which does not itself act as a chromophore, but whose presence brings about a shift of the absorption band towards the red end of the spectrum. It means the absorption at longer wavelength is due to the combination of chromophore and an oxochrome to give rise to another chromophore. It means these are the substituents attached to a chromophore which themselves do not absorb UV visible radiation, but their presence changes both the intensity as well as wavelength of the absorption maximum. For example, methyl, hydroxy, alkoxy, halogen, amino, these are the oxochrome. And oxochrome are the color enhancing group while chromophore are the color imparting group. Now, we will discuss about absorption and intensity shift or effect. Now, you have seen this diagram. In this diagram, on x-axis there is a wavelength or lambda max, and y-axis there is an intensity of maxima. Lambda max, what is the meaning of lambda max? Lambda max means the wavelength at which maximum absorption takes place. Intensity maxima means the intensity at which maximum absorption takes place. Now in this diagram, you seen that there are four types of shift or effect: bathochromic shift or hypsochromic shift, hyperchromic shift or hypochromic shift. Now, bathochromic shift means when lambda max increases. Bathochromic shift, or it is also called as the red shift. Hypsochromic effect when lambda max decreases. Hyperchromic effect or shift. Hyperchromic shift means when intensity maxima increases, while hypochromic effect or shift when intensity maxima decreases. Now we discuss these four shifts in detail. First of all, we will discuss about bathochromic shift or effect. Bathochromic shift means when absorption maxima of, that means lambda max of compound, shifts towards longer wavelength. It is also known as red shift. And bathochromic effect or shift takes place due to the presence of oxochrome or change in solvent. For example, oxochromic group like OH, OCH3 causes absorption of compound towards longer wavelength. In this example, you see there is a benzene and phenol. The lambda max of benzene is less than lambda max of phenol. Why? Because in phenol, there is an oxochromic group OHS attached and it increases the lambda max value. So when we move from benzene to phenol, bathochromic effect or shift takes place. Now come to the hypsochromic effect or shift. When absorption maxima of compound shifts towards shorter wavelength, then it is known as hypsochromic or blue shift. And this effect is due to the presence of any group which causes removal of conjugation or change of solvent. What does it mean? It means when there is a break in the conjugation or change in solvent, the lambda max value decreases. That is called the hypsochromic effect or shift. For example, the example is given here. You have seen aniline and anilinium in acidic medium. Now, lambda max of aniline is greater than lambda max of anilinium. Why? Because in case of anilinium, you have seen that in case of aniline, there is a lone pair of electron is present. But in case of anilinium, there is a positive charge. It means there is a break in the conjugation. In this case, conjugation increases in case of aniline, while in case of anilinium, there is a stop in the further conjugation. So its lambda max value is less than aniline. And when moving from aniline to anilinium, there is a decrease in the lambda max value. So hypsochromic effect or shift you can observe. Next is hyperchromic effect or shift. Hyperchromic effect means when absorption intensity or intensity maxima of compound increased, and it occurs when oxochromic group introduced. For example, you have seen there is a benzene and aniline. In the case of benzene, there is intensity maxima is 200, while in case of aniline, intensity maxima is 1430, because in case of aniline, the electronic transition increase, which increases the lambda max and which further increases the intensity of the absorption. I hope you can able to understand. And the last is hypochromic effect or shift. When absorption intensity or intensity maxima of compound decreases, then it is called hypochromic effect or shift. And this is caused by a group which distorts the geometry of the molecule. For example, you have seen two examples. One is biphenyl and other is 2-methyl biphenyl. In case of biphenyl, there is intensity maxima is 19000, while in case of 2-methyl biphenyl, the intensity maxima is 10250. In case of 2-methyl biphenyl, CH3 is responsible for distortion of the geometry of the molecule. That's why hypochromic effect takes place, and that's why the intensity maxima of 2-methyl biphenyl is decreased. So on moving from biphenyl to 2-methyl biphenyl, hypochromic effect takes place. I hope you can understand the topic. If you have any query, you can contact me at s.dwivedi@galgotiacollege.edu.